Today we're going to look at compound angles. The national 5 essential skills are Pythagoras and SOHCAHTOA. A compound angle is an angle which can be expressed as the sum of two angles together. We use this fact to help us simplify or evaluate trig expressions. For example, sine of 135 degrees can be rewritten as sine of 90 plus 45 degrees, and cos of 150 degrees can be written as cos of 180 minus 30 degrees. Once we use the correct expansions, we would be able to find the exact value for sine of 135 and cos of 150, even though these do not lie within our exact value triangles. We should note that sine of 270 minus 30 degrees is not equal to sine 270 minus sine 30. We have a special formulae to help us expand compound angles. These are called the addition formulae. So sine of A plus B is equal to sine A cos B plus cos A sine B. Sine of A minus B is sine A cos B minus cos A sine B. These will be what we'll focus on in this video. There are the addition formulae for cosine as well. So cos of A plus B is cos A cos B minus sine A sine B, and cos of A minus B is cos A cos B plus sine A sine B. It is important to note that the cosine expansion changes sign compared to what's originally in the bracket. Example 1. Find the exact value of sine of x plus 30 degrees. So this here is a compound angle, so we need to use our sine expansion. So to start it off, sine of x plus 30 equals sine of x cos of 30 degrees plus cos of x sine of 30 degrees. Now sine of 30 and cos of 30 have an exact value. So if we draw our exact value triangle, cos of 30 degrees is root 3 over 2, so we'll replace that with root 3 over 2, and sine of 30 degrees is equal to 1/2. Normally we would bring the fractions to the front, so this can just be tidied up by rewriting it as root 3 over 2 sine x plus 1/2 cos x. Example 2. Find the exact value of sine of 75 degrees. Now sine of 75 degrees can be rewritten as sine of 45 plus 30 degrees, as 45 and 30 are angles within our exact value triangles. So our expansion would be sine of 45 plus 30 is equal to sine 45 cos of 30 degrees plus cos 45 sine of 30 degrees. Drawing our exact value triangles out, sine 45 is 1 over root 2 and cos of 30 is root 3 over 2. And then cos of 45 is 1 over root 2 and sine of 30 is 1/2. From there we can multiply the fractions together. So the first will become root 3 over 2 root 2 and the second will be 1 over 2 root 2. And finally we can just add these together and they already have the same denominator to get a final answer of root 3 plus 1 over 2 root 2. Example 3. Sine P is 3/5, sine Q is 8 over 17, and we have to show that sine of P plus Q is 77 over 85. So first of all we have to show that sine of P add Q, compound angle, is 77 over 85. So what we'll do is we will look at our sine expansion. So sine of P plus Q is equal to sine P cos Q plus cos P sine Q. Now from the question we only know the exact value of sine of p and sine of q. We need to obtain the exact value for cos of p and cos of q. To help us do this, we will draw right angle triangles with the angles within it. So here we have a right angle triangle drawn with angle P, and we know that sine P is 3/5. We also know from SOHCAHTOA that sine is opposite over hypotenuse. So 3 has to be opposite angle P, and our hypotenuse is 5. Now we can use Pythagoras to obtain the missing side. Hopefully you will recognise this as a Pythagorean triple, which is a 3, 4, 5 triangle. We'll need to draw another triangle with an angle Q, and similarly we need to have an opposite of 8 and a hypotenuse of 17. Now we need to do a little bit of working to find our shorter side here. So using Pythagoras, the missing side will be 17 squared. Subtract 8 squared, all square rooted, which will give an answer of the square root of 225, which is 15. So our missing side there is 15. Now that we have all three sides in each of our right angle triangles, we can get the exact value of cos P and cos Q. So cos P is equal to adjacent over hypotenuse, which is 4/5, and cos Q is again adjacent over hypotenuse, which is 15 over 17. Now that we know each angle's exact value, we can plug this into our compound angle formulae. So sine P is 3/5, and that's multiplied by cos Q, which is 15 over 17. And cos P is 4/5, which is multiplied by sine Q, which is 8 over 17. Multiplying the first fractions together will give us an answer of 45 over 85. The second two fractions, 4/8, 32 over 85. And adding these together will give a final solution of 77 over 85, which was as required. Example 4. Find the exact value of sine of 15 degrees. Now again, 15 degrees is not in our exact value triangles, but we can rewrite sine of 15 degrees as sine of 45, this time minus 30. So we're going to look at our compound angle formulae, but this time for sine of A minus B. So sine of 45 minus 30 is equal to sine 45 cos 30. This time it's minus cos 45 sine of 30 degrees. Again, we need to draw our exact value triangles in order to obtain exact values. So sine 45 is 1 over root 2 and cos of 30 is root 3 over 2. And we're going to subtract cos 45, which is 1 over root 2, which is multiplied by sine of 30, which is equal to a half. Multiplying 1 over root 2 by root 3 over 2 will give root 3 over 2 root 2. 1 over root 2 multiplied by 1/2 is 1 over 2 root 2, giving a final solution of root 3 minus 1 all over 2 root 2. Now try these examples for yourself. Please pause the video. So for the first question there, our solution is 1/2 sine x minus root 3 over 2 cos x. And our second solution is looking for a proof. And in order to do that, you would have had to have drawn two triangles out, one with angle P, which was a 3, 4, 5 triangle, and one with angle Q, which was a 5, 12, 13 triangle. So today we've learned how to solve problems with compound angles. We need to make sure we pick the appropriate compound angle expansion. We need to use our exact value triangles to simplify the expansion. and we may need to use Pythagoras and SOHCAHTOA to help find missing terms in our compound angle expansion.